Hi, and welcome to the Ansible playbook section for Lernard.com. In the last section, we took a look at installing Ansible, and then we tested that install with the simplest possible case, that of pinging a single instance using SSH to check that it was up. We also created an inventory file named hosts to define a list of machines that Ansible would act on as a more conveniently scalable way than entering them individually into the command line. In this section, we're going to expand this model even further by moving more functionality out of the command line and into files that can be version controlled by introducing the concept of a playbook. As you can see here in this diagram, a playbook in its simplest form is composed of a list of tasks to perform. In the last section, ping was an example of one such task that used the ping module. As we discussed, there are hundreds of different modules and an absolutely huge amount of tasks you could feasibly perform, as Ansible is a well-developed ecosystem. In this section, we're going to be a bit more ambitious and useful than using ping and attempt to install Apache onto a server and configure internal firewall rules for optimum settings for a web server. Some of you may have been through the Apache install section in the basics chapter for revision, and if you have, you probably remember it wasn't desperately interesting and certainly not something you'd want to repeat. So if we can make some code to quickly automate that process, it's going to be a real win. Last section, our command looked like this. Here we're using the single word Ansible to call a module directly that would then target a list of hosts in the inventory file named hosts. Now that we're going to introduce a playbook into the mix, the command itself changes to Ansible-playbook. We can still call the inventory the same way with -i hosts. Then finally, we need to tell Ansible which playbook we want to run. A couple of things to clarify here. Firstly, the name hosts for my inventory file is arbitrarily chosen. I could just as easily have called it Wibble, or more commonly, it might be given an environment name, for example, dev or production. Secondly, the playbook file here has a .yml file name because Ansible playbooks are created in YAML, a common markup language you may well already be familiar with. But if you're not, don't worry, as I'll be going through all you need to know about it in this chapter. Without further ado then, let's switch to our trusty Ubuntu VirtualBox VM, open a terminal, then cd back into the Ansible repo we created in the last section. As we discussed earlier in the chapter, the purpose of Ansible is to configure our servers. So, as with the last section, and for all the sections in this chapter, we're going to need a server to use Ansible on. If you opted to create yourself a VirtualBox-based server, then there's no problem at all to keep going with that. Or, if you decided to go the route that I did and spin one up in the cloud, we're going to want to spin that up again now if you haven't left it running all night already. With that in mind, let's cd into our Terraform web server directory and run a Terraform apply. This is one of the few occasions I'm not going to bother with a plan. I've already started mine, so here it's saying naught added, naught changed. But of course, if you span yours down at the end of the last section, it'll probably say 3 to add. As you can see now, it's completed and outputted the IP address of my instance. So let's copy and paste that here, ready to put into my hosts file in a moment. I'll be using a Terraform server throughout the chapters in this course, but if you do want to use a VirtualBox one to save yourself a few pennies, don't worry, you'll still just as easily be able to complete all the chapters. Right, let's cd back to the root of Ansible. You can see here so far I've just got my section 2 folder, so let's copy that over to a folder named section 3 so we can build on it some more. There we go. We'll open that up in Visual Studio Code, and the first thing I want to do is find my hosts file here and change it for the appropriate IP. There are a few ways to automate this, as I think I mentioned before, such as linking it to Terraform or creating some DNS, but I think for this course it would be overkill because we've only got one server. In industry, DNS is definitely the most common way to do it that I've seen. Now our hosts file is up to date, let's create a file called playbook_web.yml. This can be called anything we like, as long as it has a .yml file ending. I think playbook_web is nicely descriptive. The purpose of a playbook is to aggregate groups of functionality and settings into a file that can be called from the command line to perform a more complex setup than you'd necessarily want to type into an actual command. If we're just running a ping, we don't really need a playbook, but most configurations in industry are going to need one, as they're going to have tens or even hundreds of settings to apply, as every possible change that we'd need to make to a server would be applied by Ansible. Remember, no manual changes will ever occur to a server in a dynamic cloud environment. Let's wade right in then and add some YAML-based settings that we want to apply to our web server. First, we write 3 dashes at the top here, which isn't actually strictly necessary in this case, as the purpose is to separate directives from document content, and we don't actually have any directives. But don't spend any time worrying about that, as it's nothing to do with Ansible. I only mention it here for completeness, as you'll probably see it a lot in Ansible playbooks and you might wonder what it is. Right, let's start with a dash, then give this playbook a name after a colon of install Apache. Now we'll specify which host groups to hit using hosts :all. You remember I was writing all in our basic command example? Well, this is the same all. If our hosts file had a mixture of different types of server, I might split them using labels such as web or db, or whatever best suited their functions, and then I could scope this playbook to only hit hosts in the web group. For now though, as we've only got the one server, all is going to be fine again. Now I'm going to write the word become and give it the value true. What this means is run as root privileged user, and is very similar to sudo on the command line. You probably remember that we're connecting into this server with the user Ubuntu, so if I tried to install something with that user, it would fail if I didn't escalate my privileges. Now I've got a name, hosts and escalated privileges, I'm going to start making my tasks. The task list here is just a list of things I want to do. Where before I was calling modules from the command line with a -m, now I can just write them here in the tasks list using YAML, along with any parameters they may need. So, let's give our first task here the name install Apache. And now I'm going to write apt, which is the module that controls apt installs. Then I give the name for the specific package I want to install, which in our case is Apache 2. And now I'm going to specify the state that I want this to be, which is present. Had I chosen absent, then instead of installing Apache on the server, Ansible would uninstall it, as Ansible is idempotent, so it's enforcing a state, in this case that Apache 2 is present. Finally, we'll write update_cache equals yes. This is the equivalent of running an apt-get update, which as it's a new server is worth doing. If you're not familiar with YAML, it's worth me mentioning at this point that white space is important. To illustrate what I mean by this, if I go and delete the tab here in front of the name, see how instantly Visual Studio warns me with these red lines that this isn't going to work? The structure itself matters. The indents have to be in the right place. The vertical lines stretching down this code show you what tab level we're at, where it's creating a new line each time I tab in another level. I used to find this a bit frustrating when I first started using YAML many years ago, but now I quite like the enforced accuracy of it. As you can imagine, people tend to avoid me at parties. Right, let's switch back to the terminal and give this a test drive. I'll cd into the section 3 folder here, and now we can use our command from the intro. So, Ansible -playbook -i hosts playbook_web.yml. Aha! It's asking us if we want to trust the machine we're connecting into. That's a standard SSH response to connecting into an unknown server. If I were to say yes here, it will add that server's ID to the known hosts file. But in a dynamically created cloud enterprise environment of the sort go-getting DevOps-focused companies are likely to have, we could be getting hundreds of these messages a day as new servers are created, and we hardly want to be typing yes to each one. So let's run this through, and then we'll need to add a global fix somewhere. Okay, there we go. You can see there it's listing our install Apache task and saying changed, and the IP address of the server it changed. That's because Apache wasn't previously installed, but now it is. If we jump back to Visual Studio Code, we can use our ansible.config file to apply a global fix to that issue of SSH host confirmation. All we need to do is write host_key_checking equals false here like this, and now Ansible won't ask us for any more confirmations. There are other ways around this. We could feasibly automate the population of our known hosts file, but this is much easier. Let's quickly run that command through again now. And you can see that now it's declaring OK rather than changed for our Apache install, because the server already had Apache on it, so Ansible just confirmed that yes indeed, Apache 2 was present as dictated in its desired state, and then it didn't mess with it any further. To prove that Ansible has done all this correctly, let's go to a web browser and try browsing to that server on the same IP address we've been using to hit it with Ansible. And there we see the expected Apache 2 default page, proof, if any were needed, that we have made a blank Terraform server into a functioning web server. Obviously, even the ability to do this without having to log onto a server is pretty handy, but the great thing about playbooks is that they allow us to have extremely complex setups codified in a single place that can be run without mistakes again and again. So let's add a bit more here to illustrate that. As this is a web server, I reckon we should lock it down to only web traffic, plus SSH so that we don't accidentally lock ourselves out of the server completely, of course. Let's create a second task with a new name here, allow port 22 for SSH. And now I'm going to use the IP tables module to alter the firewall. There's a few options to fill out here. First, chain, which is the type of firewall rule. Input is for incoming traffic in this case. We want to specify a destination port of 22 because it's SSH. And because we want to allow it rather than block it, we write jump followed by accept. Finally, I'm going to specify a protocol here of TCP. Now at this point it would be understandable if you were thinking, this is all very well, but how on earth can I remember all of this if there are thousands of modules? Well, firstly, if we do a quick Google search here for the word Ansible followed by IP tables, we immediately get shown the Ansible documentation for IP tables and how to use it, plus all the options we can write under it. I must say that of all the DevOps tools I use, Ansible's documentation is absolutely top-notch. With regards to how you might know what modules are available though, I think the best thing to do is assume that whatever it is you want to do, it's available. When it comes to Ansible, the only limit is your imagination. The ecosystem is just so massive, and so many of the commands are so flexible that it's safe to assume that literally everything you want to do to a server is possible. Okay, we've got our rule for SSH there. Let's use the beauty of copy and paste to make a load of similar rules for some of the relevant ports. I'm going to super fast forward this so you don't have to wait ages while I do it, and then we'll discuss what I've added. Remember, by the way, that all this code is available free at the Lernard.com GitHub page, so if you don't want to write some or all of it out, do just go and clone the repo and steal it if you haven't done so already. Let's take a look at what's here then. I've copied a rule that only allows port 22, and then made identical rules for port 80 and 443, which are our web traffic ports for HTTP and HTTPS. I've also added two standard rules to allow established and loopback connections, which prevent funny side effects of being too zealous with IP tables firewalls. I've allowed all outgoing traffic, and though I could be more specific here, I don't want to drown us in rules right now. And then finally, I've blocked everything that isn't in the above list. Our setup is looking a little bit more complex now, and we definitely wouldn't want to have to go and write all of this out in a command, or God forbid, actually manually do all of these things on every single one of the servers we owned. So the power of the playbook is starting to shine through. Let's go over to our terminal once more and see what this looks like if we run it. First, we'll use the same Ansible playbook command again. And there we go. Now it's run through, you can see a couple of things here. We can see a list of all the things it's applied, which of course is our tasks list we just created. And we can see that the firewall rules were new because they have changed written next to them, but the Apache install was already complete, so it just confirms that it's in the state we want it to be with an OK. As before, we can jump back into our web browser and confirm that once again we're still serving the default web page and haven't broken our server or done anything too terrible to it. I've got a fair few years of network-related work behind me, and I still quite regularly make firewall changes that completely shut me out of a server. The great thing about the cloud though is that if you do make some kind of horrible mistake, you can always just delete the server and start again, and it won't take more than a couple of minutes to spin up another one with a better set of rules. Okay, that's it for our simple playbook. Hopefully you can see how great it is to be able to add settings to a version-controlled document rather than having to do stuff manually. Like the Terminator, Ansible doesn't get tired or make mistakes. It will just perfectly configure our server farm each and every time it's run. You can probably tell I'm a huge fan of this product, because when it first came along, it solved at a blow so many of the problems that I'd been trying to solve in traditional engineering teams. Finally then, as always, let's behave as if we're working as real DevOps engineers and commit our code back to the repo at the end of the day. So, git status. Oops. Root to the repo so we can actually see our work. Git status. There we go. Now git add a, git commit -m with a sensible commit message, and finally git push origin master. Great! Our Ansible model is starting to look a lot more like it would in industry if you encountered it in an enterprise repo, but we're still missing a few key parts that's going to make this more functional. So in the next section, we're going to expand our playbooks out to include roles. Hopefully see you there.